Chemical properties of alkali metals. Alkali metals are highly reactive. Their high chemical reactivity is due to their large size and low first ionization energy. And down the group the size increases, so their reactivity also, chemical reactivity also increases. Okay. First chemical property is reaction with air. So air contains oxygen and moisture. Alkali metals react with oxygen present in the air and form oxides, and also they react with moisture present in the air and form hydroxides. And they burn very fast with oxygen and form monoxides, peroxides and superoxides. Okay. And lithium forms Li2O, that is monoxide. Lithium form monoxide, sodium form Na2O2, that is peroxides, and all other metals form superoxides. Okay. So the reaction will be 4Li plus O2 gives 2Li2O, monoxide. Lithium monoxide is obtained, and sodium 2Na plus O2 gives Na2O2, that is sodium peroxide is obtained, and all other metals in the case of potassium, rubidium and cesium. These metals are large cations. Okay, so in the case of superoxide, that is there is O2 minus ion. These O2 minus ions will be stable only in the presence of these large cations. So they form superoxide, and the reaction will be M plus O2 gives MO2. Superoxide is obtained. Okay, so these are the reactions with oxygen. Okay, and in all these cases their oxidation state is +1. Next, this lithium is having an exceptional behavior, that is the nitrogen present in the air reacts with lithium and form lithium nitride. Okay, so the reaction will be 6Li plus N2 gives 2Li3N. Lithium nitride is obtained. Okay, because of their these alkali metals are highly reactive. So because of their high reactivity with air, these are kept immersed in kerosene oil. Okay, these are the first property, the reaction with air. Okay, alkali metals on reaction with air. Next property, reaction with water. Reaction with water. With water, alkali metals from corresponding hydroxides and hydrogen. 2M plus 2H2O gives 2M plus 2OH minus plus H2. H2 gas is liberated. Okay, this tendency, that is alkali metals, the reactivity with water depends upon the E0 value, that is electrode potential. Okay, so greater the negative value of E0 means the reaction is less vigorous, because less vigorous, and vice versa. Okay, the reaction is less vigorous, and if the lesser the negative value of E0, the reaction is more vigorous. For example, in the case of lithium, lithium is a strong reducing agent and it is having more negative E0 value because they are smaller in size. Okay, and it is having high hydration enthalpy, so it's a strong reducing agent, and its E0 value is negative, E0 value is more. So in this case the reaction is less vigorous, but in the case of sodium compared to lithium, this is having less negative value of E0. So the reaction is more vigorous. Also in the case of all other alkali metals also reaction is more vigorous and sometimes they catch fire. Okay, this is a reaction with water. Okay, they also react with alcohol, that is alkali metals also react with alcohol and hydrogen halide, and the reaction will be 2M plus 2C2H5OH gives 2C2H5OM plus H2 gas is liberated. Also with HX also reaction takes place, 2MX plus H2 gas is liberated. Okay. Now next reaction is reactivity towards dihydrogen. Third reaction with dihydrogen. Okay, reaction towards dihydrogen. Alkali metals reacts with hydrogen, dry H2, that is dry dihydrogen, and form hydrides, and the reaction takes place at 673 Kelvin. And in the case of lithium hydrides are obtained at 1073 Kelvin. Okay, and these are ionic in nature. These hydrides are ionic in nature and they have high melting points, and reaction will be like this, 2M plus H2 gives 2MH. This is ionic in nature. Okay. Fourth reaction, reactivity towards halogens. With halogens they form halides, and halides are alkali metals vigorously react with halogens and form halides, and these halides are ionic in nature except lithium halides. Okay. In the case of lithium halides, they are covalent in nature. Lithium halides are covalent because lithium is smaller in size and halogens are larger anions. Okay, larger in size. So during the formation of lithium halide, what happens? The electron cloud will shift more towards the X ions, okay, halogen ions, and this is called as polarization. So due to the polarization, they are covalent in nature. Okay, especially in the case of lithium iodide. Iodine is bigger in size compared to other halogens, so the polarization will be more, so they are more covalent in nature. Okay, so all other halides are ionic in nature. These are the reactivity with halogens. Next, reducing nature. Next, reducing nature of alkali metal. Alkali metals are strong reducing agents because of their larger size. They can easily lose electrons. Okay, their outermost electron can be easily liberated. Next, they are having low standard electrode potential or E0 value. Or their negative E0 value is more. That means they have low standard electrode potential, and their reducing character increases from sodium to cesium. Okay, but lithium is the strongest reducing agent among alkali metals because strongest reducing agent. Okay, lithium is having smaller in size, that is lithium plus ion is smaller in size and they have high ionization energy. Okay, high ionization energy, but in aqueous solution they are heavily hydrated and they have high hydration enthalpy. Okay, they have high hydration enthalpy which compensates this high ionization energy. Okay, so they can easily lose their electrons, so it is having negative E0 value is more, or we can say they are strong reducing agents. Okay, and in this case it gets converted into gaseous state, that is this is called as sublimation energy. The energy released is sublimation enthalpy. Okay, and this gaseous state, it releases one electron and ionization energy is released, or ionization enthalpy, this much energy is released during this process. Okay, and in aqueous solutions what happens? With water, this M plus ion is hydrated and the energy released is called as hydration enthalpy. This hydration enthalpy in the case of lithium is very high. Okay, so this hydration enthalpy compensates with this high ionization enthalpy, so lithium ions can easily release its electron. So due to this high hydration enthalpy, this lithium acts as the strongest reducing agent. So lithium is the strongest reducing agent and sodium is the least reducing agent, because down the group the reducing character increases. Okay, so down the group the reducing character increases. Lithium is the strongest reducing agent and sodium is the least reducing agent. Okay.